Hello friends, I welcome you in lecture number 24 on Laplace transform. In this lecture also we will discuss one question on finding inverse Laplace transform using partial fractions. So here we are asked to find out inverse Laplace transform of this function 5s square plus 3s minus 16 divided by product of three linear factors s minus 1 times s minus 2 times s plus 3. So we can see that degree of numerator is 2 and degree of denominator will be 1 plus 1 plus 1, that is 3. So we have degree of numerator is strictly less than degree of denominator, and therefore this is proper rational function. And we know that if we have proper rational function, then partial fraction decomposition is possible. So I can write this rational function as sum of three partial fractions corresponding to each linear factor. I can write partial fractions in this way: c divided by s plus 3. I have three linear factors. So for s minus 1 I write constant a in the numerator. Similarly b and c for s minus 2 and s plus 3. Now all we have to do is we have to find out values of these constants a, b, c, and after finding values of these constants we can see all these three functions are in this form 1 over s minus a, and we know that inverse Laplace transform of this function is e raised to at. So we can use that formula. So what we are doing is we don't have formula for the inverse Laplace transform of this rational function. So using partial fractions we are converting this function in terms of those functions whose inverse Laplace transform formula is known to us. Now to find out ABC, we multiply this whole equation by this product s minus 1 s minus 2 into s plus 3. So I multiply both sides by this product of these three factors. So left hand side will be 5s square plus 3s minus 16. In the first term s minus 1 will cancel out and we will have a times s minus 2 times s plus 3. In the second term s minus 2 will cancel out and we will have b times s minus 1 times s plus 3, and in the third term s plus 3 will cancel out and we will have s minus 1 into s minus 2. Now we think that for which value of s this s minus 1 becomes 0. So s minus 1 becomes 0 if s equal to 1. So first we take s equal to 1 in equation number 1. So corresponding to s equal to 1, we can see that if I take s equal to 1 here, I will have 5 plus 3 minus 16 equal to, for s equal to 1 these two terms will be 0 because we will have 0 in the product, and non-zero contribution will be from this first term. So for s equal to 1 I have 1 minus 2, that is minus 1, 1 plus 3, that is 4, and this is 8 minus 16, that is minus 8, and this is minus 4 times a. Therefore a equal to minus 8 divided by minus 4, that is 2. Value of a is obtained by taking s equal to 1. Now we take s equal to 2 because s minus 2 will be 0 for s equal to 2. So now we see what we can find out for s equal to 2. So on the right hand side s minus 2 is in these two terms. So these two terms will be 0 for s equal to 2, and here we will put s equal to 2 and here also. So 5 into 2 square, that is 5 into 4 plus 3 into 2, that is 6, and minus 16. Or we can write one more step, we take s equal to 2 in left hand side 5 into 2 square plus 3 into 2 minus 16, and here we take s equal to 2. These 2 will be 0 for s equal to 2. So here we will have b times 2 minus 1 and 2 plus 3. So this is equal to b times 2 minus 1, that is 1, and 2 plus 3, that is 5, and this is going to be 20 plus 6 minus 16, or 20 plus 6 minus 16. Okay, we write one more step, 20 plus 6 minus 16, this is equal to 5 times b. 6 minus 16, that is minus 10, equal to 5 times b. Therefore 10 equal to 5 times b. Therefore b equal to 10 by 5, that is 2. So we obtain value of b, which is 2. Now we take s plus 3 equal to 0, and we will have s equal to minus 3, and we now take s equal to minus 3 in equation number 1, and we will be able to decide value of c. So now we put s equal to minus 3 in equation number 1. Left hand side is 5s square plus 3s minus 16, 5 into s square plus 3 into s minus 16. Okay, so I have taken s equal to minus 3 in left hand side. For s equal to minus 3, these two terms will be 0, because s plus 3 will be 0, and we have c into s minus 1 into s minus 2. C into s minus 1, that is minus 3 minus 1 into s minus 2, that is minus 3 minus 2, and here minus 3 square, that is 9, minus 3 into 3 minus 16. This is equal to c times minus 4, and this is minus 5. So this is going to be 9 into 5, 45, and 16 plus 9, that is 25, and this is minus 4 into minus 5, that is 20c, and 45 minus 5, that is 5 minus 5, 0, and 20 equal to 20c. Therefore we have obtained c equal to 1. So once we obtain values of these constants, we substitute them here, and we have converted our function in terms of those functions whose formulas for inverse Laplace transform are known to us. Left hand side is 5s square plus 3s minus 16. Therefore 5s square plus 3s minus 16. In the denominator we have s minus 1, s minus 2, s plus 3, and a divided by s minus 1 plus b divided by s minus 2 plus c divided by s plus 3. Value of c is 1, value of b is 2, and value of a is also 2. And we have s minus 1, s minus 2, s plus 3. So a and b are equal to 2. Okay, fine. So we have converted this function in terms of simple functions whose inverse Laplace transform formulas are known to us. So now we take inverse Laplace transform on both sides. Inverse Laplace transform of 5s square plus 3s minus 16 divided by s minus 1 times s minus 2 times s plus 3. This is equal to 2 times inverse Laplace transform of s minus 1, that is e raised to t, plus 2 times inverse Laplace transform of 1 over s minus 2, that is e raised to 2t, plus inverse Laplace transform of 1 over s plus 3, which is e raised to minus 3t. So we have used this formula, L inverse of 1 over s minus a equal to e raised to at. So in the first term a equal to 1, in the second term a equal to 2, and in the last term a equal to minus 3. So in this way, this method of partial fractions is helpful in deciding the inverse Laplace transform of this type of functions. This question was asked in GTU Winter 2011. So I hope you like this lecture. In upcoming lectures we will discuss some more problems of this type.